morning. Welcome to lecture 20, Safety Data Visualization Tools. In lecture 19, we started this, and today we will complete the visualization part, and this comes under descriptive safety analytics under the subject or course safety and risk analytics. So, what we will be discussing today: scatter diagram, stratification and control chart. Again, I will keep the discussion simple. Like in the previous lecture, I talked about check sheet, histogram, Pareto chart, cause and effect diagram, and today, as I told you, these three things will be discussed. So, there are particularly with reference to control chart, much more treatment can be made, and that we will do later on. And today I want to just give you that how this visualization tools can be used, can be developed given a data set, and how to interpret it, what is the purpose of it. So, let us start with an example. You see here we have given a data table, and in this data table the first column is months, second column talks about orderliness, third column talks about tools and equipment. Actually, then what are these values? These values are nothing but the column 2 and column 3 numeric values are nothing but basically number of unsafe acts and conditions observed in different months based on certain inspections and under orderliness and tools and equipment use point of view. So, we have created two variables. Suppose if I say this is x and this is y, then we created two variables, and this month is nothing but observations number I. So, I equal to 1, that means we have 12 observed data with reference to x orderliness and y tools and equipment, and these values, inside values are numbers, but please keep in mind, although I put it in numbers, but you can think of other measurement also. Instead of writing number of unsafe action and condition, if I write these are the gross risk codes in the month 1 from the orderliness point of view, this can be other kind of scores also. So, although the count data I have given you here, but this can be some kind of numeric continuous data also can be created. Essentially, we are interested to discuss on scatter diagram. So, scatter, S-C-A-T, what is the scatter? Scatter diagram is basically used in numeric data primarily. Also count data you can use it, you get the information. Scatter is nothing but when you have you have two variables and you want to understand how the two variables behave together, that is the case. So, in the x, so you create one put one variable on the x side, x axis, and another variable on the y axis, and then the joint occurrences like some kind of coordinates. You can see that first observation x is 42 and y is 20. So, come here somewhere x is 42 here and y is 20 means somewhere here. So, I can say 20 means this one. So, this is the observation. So, you basically draw a graph kind of thing where x and axis having one variable values and y represent one variable values, y axis represent another variable values. And please understand, although I have used here this count data, because count data also can be plotted like this, but numeric data or other way I can say in the continuous data scale, that means the measure is any measurement possible within the operating range, that kind of cases it is basically started, but it can be used in the count data, because it will not give you any odd information, but it gives you some kind of relation. So, scatter diagram actually is a pictorial or graphical representation of relationship of two variables. Then how do you compute the scatter, how do develop the scatter diagram? You will be developing the scatter diagram by graphically by this way. You put one variable across x, another variable across y, then you are getting a two-dimensional plot kind of things, and there then you find out each of the observations. So, each observation is a basically two coordinates will be there, like first observation 40 to 20, similarly last observation 49 and 20. So, I can see, you can see 49 and 20. So, that means this one is the last observation. In between there are many observations and they are getting a place here. So, that way it will be constructed, and it is a easy thing to do, it is not a big thing. You go to use the data in Excel and ask Excel to do, within a fraction of second it will do. Now, issue is that what inference you can draw from this, what the benefit you are going to get if you do this kind of scatter diagram. As I told you, the scatter diagram talks about the relationship between two variables. Here, in this particular case also, you see a very interesting pattern is observed. What is the pattern? Orderliness, because we are talking about these are basically unsafe acts and condition. That means the orderliness related unsafe acts and condition, and tools and equipment is related unsafe and condition, that there is a positive relationship. Means if violation is increasing in terms of orderliness, at the same time it is increasing in terms of use of tools and equipment point of view. So, that means there may be some hidden other reasons why it is happening, but for the plant, what we consider, or the equipment, what we have workplace, what we have considered, there this phenomena is increasing. That means one kind of violation, if committed by the stakeholders or the people there, then another kind of violation also, that is chance is more. So, that is the crux of the matter. So, in general sense, you can say that x, if this is x and this is y, that means x and y are positively related. You may find out, suppose instead of the same violation, if you put this side that violation due to orderliness, and if you put this side another variable called maybe the frequency of inspection, instead of that another violation, if you got frequency of inspection, you may get a different picture. Oh, sorry, this is just okay. Frequency of inspection if increases, then this will be reduced. Okay, so okay, let me that means the other way, the negative will come. So, let me put it another way. So, I am doing like this. Suppose this side, let me, because frequency of inspection is inspection frequency, and this side if I say that tools and equipment related unsafe acts, what will happen? If you increase the frequency, it is expected that the violation will be decreased, because people will be more alert. So, that time you may get some kind of this kind of figure. If this happens, we say x and y are negatively related. So, the purpose of scatter diagram is just to know this kind of things, positive, and how the two variables are varying or co-varying, rather better word, two variables are co-varying together. Is it positively related or negatively related? Scatter diagram is the first thing what we have to do if you are going to do any kind of regression modeling. Suppose simple regression you want to do, where you want to see that violation of tools and equipment are a result of violation of orderliness, then you can think of that this is y and this one is x, so you may think that y is function of x. Then you may do some kind of regression analysis, and that regression some equations you can develop. So there you have to first stage you do the scatter plot of the two variables. If there is really a relation, then you go for this. And here we are finding out there is a linear relation, that means positive relation. So that means the function will be like this: beta 0 plus beta 1 x plus epsilon, some kind of error or error, because everything, the straight line, this is the equation of the straight line, but points are not along the straight line, it is points are above below the straight line. So that difference deviation is consumed by the error. This kind of discussion or this analytics we will be discussing later on under regression. So I hope that you got the basic idea of scatter diagram. The purpose also you understand. The next in the group is stratification. Actually, in order to understand stratification, so you please understand the strata. How many strata are there? Strata can mean basically when I was giving you an example that I want to know the safety performance of workers, and if you mix the performance of young, middle-aged or old, or young and experienced workers, then you try to understand how the workers are behaving safely or unsafely, then you will not get the clear picture, because the behavior pattern of the experienced people and inexperienced people will be different. But when you are computing the, suppose the central tendency or the spread or something like this in terms of safety performance measured by certain units, then what are actually happening, you are basically misguided, because the two groups behavioral patterns are different. Under such situation, it is better to consider that there is two strata from the experience point of view, less experienced and experienced group of workers. So you have to analyze, you have to first segregate the data, safety performance observations what you got from the young people and old people separately. That means age adjusted information you have to collect. Other age wise. Similarly, suppose you think of two locations. One is very highly hazardous location, a lot of heat, humidity, and another one is some office kind of work. And then you have collected the safety performance data from both the places and mix them, and then you are saying this is my safety performance. This doesn't give you the clear correct picture. It gives you a gloomy picture, in the sense it's a incorrect one, because you have mixed the shop floor with the office. So there office and shop floor, that kind of stratification is required. So as a result, when you are discussing on, suppose you are basically almost all industries across the world, the incident records, these are basically plotted and seen that what is happening over time. So like I can say that over quarter what is happening, okay, or other kind of variables point of view what is happening. But please understand one thing, if there are such stratum, one stratum characteristically different from the another stratum, then you have to analyze them separately, and that is the concept of stratification. And when you talk about sampling also, if this kind of stratification is required, then first level work is do that stratification, and after that collect the sample for each of the stratum. Each of the strata you collect. Okay. Here very clear example is given here. Suppose we are interested to see the Pareto chart, in that means this is basically Pareto chart from incident point of view. This is a hypothetical one. We have found out that there are 4 categories of incidents, and when we plot, we got Pareto plot, we got like this. But please understand, this one is taken for the entire plant itself. Okay, and this is this picture you are getting. What you are getting the picture, that for I3 this much and something like this. And from the incident point of view, you understand that I3 is occurring more. That's all. and others are comparatively much less. This gives you information about I3 only. It doesn't give you information anything else. Now, if you want to see that risk control point of view, what is happening, because ultimately it may so happen that the risk control system has the capacity, different types of capacity of reducing or influencing the incident, different types of incident it is happening. Here, if you see the data from this control system also R1 and let me see again. Suppose R1, R2, R4, R3. So you are getting a different picture. You just see, obviously because of I3 is so much high, so ultimately your every cases here I3 is more, but there could be situation when you may find out for a particular risk control system, maybe I3 is less whereas I4 is more. Something like this. You may find out I3 like this and I4 like this. That also will happen. Okay, so here the data is data may be like this. So then the overall picture with the risk control system specific picture, that is a difference. So that is important part you have to keep in mind. This is basically, that means with one risk control system you stratified. Okay, so another one, basically suppose you want to see over quarter. Okay, so every quarter how it is happening. So if you think that there is a change in a particular quarter from the inspection points of view, meaning inspection quality point of view, number of point of view, then it may so happen that on a particular quarter it will be more because of maybe more number of things. So that kind of situation, if it is there, or there is no regular or common program across the quarters, so sometimes it is high, sometimes it is low, something like this, then it is better to see the results quarterly, not the overall entire things. Okay, so these things are basic things, so you all understand that it is to be done. But stratification gives beautiful results when essentially the data generation and the behavior of the system is such that it across different strata, different kind of pattern you will observe, and that may be possible. And if you merge them together, you do not consider the strata, you just merge them together, then you will get some kind of smooth behavior. That smooth behavior is not the true sense, true behavior across the different strata. So that's why the stratification is very, very important. Okay, I told about age factor, experience factor. These are very important example from stratification point of view. One example I can give you, the COVID case. You just see, you all know that the COVID, we are suffering from COVID for past 2 years, and it's a huge havoc across the world. Now, if you see the COVID case across the age groups, you will get a different picture. If you see the COVID case based on the comorbidity pattern, you will get a different picture instead of seeing the COVID cases in totality for a particular country or particular location or particular region. So a particular region, one kind of information you get, but in another way, when you stratify the things in terms of age groups, in terms of comorbidity pattern wise, so you will be getting a different picture. And these are very important. And in safety and risk analytics, when you have data, and you must be clear that you have to first understand whether the data came from different strata or not. If it is from different strata and the strata are not homogeneous in nature, so then stratification is a must. Last one of the visualization tools what we plan to discuss is control chart. Now, control chart, a very interesting thing. Control chart is used in quality control. This is heavily used in quality control. Mainly the route is like this. It's a online quality control, I can tell you. Online quality control. What it is done, suppose you just think of a process. Suppose the process, there are two variables, one is your temperature, maybe another one, suppose pressure. These two critical variable for the process. Many chemical processes are like this, affected, quality affected by temperature, pressure. Many manufacturing processes, other kind of processes are also temperature and pressure. If these two are very critical, then you require, these are the process variable, these are known as process variables. So, and there is operating range for this variable. If I say this is my x variable or x1 and this is x2, these two variable, so there is a range of operation for x1 temperature, another range is there for x2 which is pressure, and this range is set in such a manner that the ultimate aim is what? The output quality in the quality control, output quality will be as per the desired specification, within the desired specification. So that's why you, and if it goes beyond the range, means the quality will be hampered. So as a result, as the operator is setting the process temperature and pressure and all those things are happening, so there can be some assignable reasons by which there could be change in the process parameters. So as a result, over time, when this is time, where you basically, suppose you are monitoring the temperature, what values it is happening. So you may find out a particular, suppose you think of a sampling scheme that at certain interval you will see what is the process temperature. So T1, T2, these are the intervals. So here you found something like this is the temperature, second time this is the temperature, third time this is the temperature, fourth time temperature, or in last time temperature is like this. So if you plot, you are getting something like this. This kind of plot, when you make over time, this is known as run chart. Run chart. How the process is run with reference to temperature. Similarly, you can create another one with reference to another one you can create with reference to pressure. Okay, so you may get something like this. So this talks about how the process parameters behave. The question is, can this feature, this phenomena be utilized in the safety domain? Can we say that there are certain safety characteristics, safety features, which or safety outcome is a result of such indicators like leading indicators or lagging indicators? So can we identify the leading indicators which ultimately influence the safety outcome, like incident, injuries, something like this? And can we over time monitor this? The run chart kind of things you can do. So if you do this, you will know that what is happening. But as in the workplace safety point of view, it is not the process parameter kind of variable, so it is difficult. But for the process point of view, where such, because if the pressure goes beyond certain range, it will be a safety issues. Here you are talking about quality point of view, but it can be also safety issues. Okay, so those critical points, although the safety points in terms of this pressure temperature here, this will be rare events, but even then there could be a pattern towards that undesired state, so that can be monitored using this kind of control chart. So we have to utilize this capability, this basically run chart capability. I have not talked about control chart so far here. This basically I am talking about run chart, but actually it will become control chart. The reason is you are basically, if you know the process and the process behavior from the population point of view, and then you know what could be the limit of temperature or pressure or any other control factors change, the range of changes which are acceptable, then you can create upper control limit, lower control limit. You can create also central limit. So these limits, once you create for a particular process or a system, and after that you see the run chart kind of things what is happening, then you will find out interesting phenomena. So what are those things I will discuss in the next 2-3 slides. So control chart development is a, or design of control chart is an important part of activities of the team who are going to use it. So we will later, some other lectures, in the coming lectures, we will discuss in detail how the design is made or how control chart is developed. But as today I am basically trying to tell you the visualization part of it. So that's why I restrict to the visualization part of it only. Now these are the points, some of the points what is written here. These are very pertinent to control charts, and we will discuss again. But at present, I will go to a control chart. Suppose this is the issue. We'll spend maybe some time, 5 minutes time here. You just see what actually we have done here. We have seen that, okay, for the accident or incident I3 in past 21 months, what is the number pattern? Because incident occurrence is a random variable. It's a random phenomenon. Now, so if I know that this is the way the incidents are occurring, okay, so in first month 6, second month this kind of thing, and if you plot this side month and this side the number of injuries or incidents, so you are getting a plot like this. You can see the plot, some kind of zigzag lines are you getting, these lines you are getting. So this is basically this one. So this kind of this what you are getting, this is basically some kind of, this is a plot you are getting. So this plot is talking about that in terms of incident occurrence point of view, how for the particular incident I3, so how your system or the workplace or the plant or the department for which you have done it, it is basically behaving. You can find out the number started is 6, then slowly increases, again increases and then decreases, something like this. So this is fantastic. This is what I have told you in the previous one. But here two important things you have to understand. One is, when, if it is, suppose if it's a system, let it be a process or a facility, you have designed the facility. You design, why you design the facility for work point of view, for safe work point of view. Okay. Now what is the, based on your design, there are two things happens. The design, some amount of, suppose if this is the risk side, some amount of risk because of faulty design or because of not knowing that what kind of hazards are going to come. So that's why that is introduced into the system during design, that is we say residual risk. You all understand the residual risk or inherent risk. Okay. Now also you have seen that entropy risk kind of things. If you recall, I think I have given this lecture earlier. So entropy risk, and then certain amount of risk are introduced here. So residual risk increased this much, again here residual risk is increased. So as far as the workplace or plant or the system point of view, what is the age? depending on this, there are common risks, some amount of risk already inbuilt. Now, if this risk is capable enough to cause certain number of incidents, so then that is basically we can say the common cause, basically, because these causes are such that it is inherited in the system in such a manner. That is why I want to explain, because I think that is pertinent and relevant. So some common cause is the system by its design, by the I can maintaining and operating the system in such a manner that it is common. So that means these many causes will be inherent to the system. Here and there it will be there. So now in control chart we want to understand this, that what is the common portion, that the variability in terms of operands what you are observing in terms of maybe number of incident, or in terms of any other like process parameters you have seen, the pressure, temperature, in terms of or variability of the operating values. So what is the common within the system? So these common things are basically, that's why we create upper control limit and lower control limit. Means we are trying to tell you that the system is such that the spread in terms of here number of incident, it will be within this. It will range between this and this. So another important part is that although the values, NOI values will be in between this, but this will be haphazard and random. It should not be something like this or something like this, like this. There should not be any pattern. So that means if you first set the lower and upper control, the range within which this particular variable values will lie, and that from the common cause point of view, because which is almost inherited in the system, maybe based on design, based on your practice, based on your day-to-day operation, all the system components collectively, this is the overall common behavior of the system. Then first find out this, understand, identifying this UCL and LCL or calculating this is a real task also. So we will be discussing later on, but for the time being, you please understand only this one, that you are basically generating a certain range which is UCL minus LCL, this range, where because of your system that the status, the outcome variable here, if it is number of incident, it will lie within this but randomly. Then that if you want to improve under such situation, then you have to change. Maybe there is a need of design change, redesign is required. Means some kind of innovative or breakthrough improvement concept you have to use. But apart from this, what will happen? Sometimes you may find out that here in this case it is well within the two limits, and they are random also. Now, but it may so happen that find this one, but suddenly you find some point is there. Okay, so this will be not be used. Some point is there, or some point is here in the run chart. You are doing it. So that means this one beyond UCL, this is beyond LCL. Depending on whether it is good or bad, they depend on the what kind of variable you are measuring, and from safety point of view, if it is number of incident, definitely this is a good indicator. But we at present I am not considering this. So that means it is good or bad, that is not the case. Case is that this is not caused by the common causes of variation. This is not caused by the common causes of variations, because common causes of variation results values within this range. So this cause is known as assignable cause. Assignable causes are there. So that means if this is the 12 month, so that means in 12 month in that particular process or in that particular plant or the department or the location for which the dish is developed, something different has occurred. And that is the beauty of this control chart. That means once you find out that what are these are known as out of control observations. So you have to find out out of control observations. Also there will be out of control pattern. Maybe it is not beyond the that UCL or LCL, but there is out of control. That means pattern, means something what will happen, you may find out the data is like this. It's showing some increasing pattern. So if you find out this kind of behavior in the control chart, in this run chart, it is control chart when you have set the UCL and LCL as well as CL. CL is the middle average value. So this is CL, central line. If you create and you find out this kind of out of control, there are many patterns which we will discuss later on, that how to read the control chart. The many patterns are there which talks about different kinds of defects in the process. In the safety domain, why can't this kind of charts will be used? In the quality domain, it is heavily used. So that's why I thought that this is important control, important I can say visualization tools when you are dealing with suppose high risk plant where the process parameters are important. So let us use this kind of charts, and I am sure from the production point of view, reliability point of view, quality point of view, these things are in practice. Now use this data, you don't have to do anything different. Use this data, bring this data in the safety domain also, because maybe it may so happen that it is increasing, and here you have taken the control and it is decreasing, something like this. But this signature is important from safety point of view. It may so happen that one day, even although you may miss it, and it will go beyond the safety range, and it will create a problem. So such kind of pattern can we not identify or monitor with the help of control chart. So as you are doing it in the process from the quality point of view, reliability point of view, so I am 100% sure the industry is using this from the safety point of view also. So with this, I can tell you that we have given you some idea that what are the visualization tools commonly used in the different domains, and although these tools I have taken from the quality engineering or quality control domain, but these are applicable in other domain and are being used also. Apart from this, there are many other visualization tools. Okay, so those tools can be used also, but I don't want to make the things more complicated here. These 7 tools, visualization tool what we have presented, these are quite good enough to start with, and other tools that as a customized manner that you can make tailor-made visualization tools for the purpose for which you are doing all those exercises. Thank you so much for your hearing, and these are the references. Sometimes I am forgetting to mention the references while writing, while talking, but please keep in mind that we have citing at the under references what are the resources literature we have considered. Thank you so much.